Hello, everyone. Welcome back. It's great to have you back with us again. Today, we will talk about MAC addresses and layer 2 switching and everything around this layer 2 aspect of Ethernet MAC addresses. By the way, just to be clear, we're talking about Ethernet MAC address in this case, not BACnet to MAC address. My name is Ping. I am CEO of Optigo Networks, and I have here with me Thomas McGee, our sales engineer.
Yes.
Good morning, good afternoon, wherever you come us from. And as always, if you have questions, fire them over through this GoToWebinar interface. Put them in the chat, and Natalie in the back end will send them over to Thomas and I. Don't wait. We will field the questions as we go. Again, survey at the end is fantastic. And this session, as always, is recorded. If you missed anything, it is available on our YouTube channel. Let's get going. Next session is tomorrow. And it will be Thomas and Ryan Hewson, our Director of Business Development. I am stepping away now from this mini series. We're going to go more into our products, how our products can help identify problems, can help solve some of the problems they have, and how we can build a solution to create a proper scalable and secure network for your customers. Tomorrow is our next session at 10:30 a.m. Pacific time, 1:30 p.m. Eastern time. We'll be talking about our protocol, Optigo Connect and Optigo OneView, applying everything we've talked about in the last couple of weeks, a few weeks actually, and how we can build a solution to create a network. Let's get into it. Well, today we're talking about the Ethernet MAC address. Thomas, you're up.
Thanks very much. Yeah. So we kind of have two addresses we'll predominantly be dealing with. As we've discussed, we've had our IP addresses, so that's more our layer 3 routing and everything. It's all built on the core for the IP addresses. However, our MAC addresses it's an address that is set to your device. So this is not going to change. This is not something like DHCP where we're releasing it, where we're renewing it, and it's changing from time to time. This is something that's set on your device when it is issued or when it comes from the supplier. As you can see, there'll be generally two parts to it. There's going to be the organizationally unique identifier. So that's going to be when a producer or supplier, they're going to go to some admin, some control, and they're going to ask for or buy a set of IP address or a set of MAC addresses. And these MAC addresses will all be consistent for a certain section. For the first part, our organizationally unique identifier, and then they can be individual with the specific to the device itself or which individual one we're dealing with. So with these, as I was saying, these are set, these are stuck. So these are not going to be renewing, they're not going to be changing. As we could actually run, we possibly actually could, and it has been done back in the 80s and 90s, but obviously we have a lot more functionality is needed nowadays. You can actually run a layer 2 switches. You could have devices running with just the MAC addresses. However, this is going to be on effectively a LAN. If you remember, we've spoken about our LAN and our WANs are wide area networks, and a router separates them. Inside our LAN, our only local one, that actually could work. However, when we're going out to routing in the whole world, MAC addresses and all this would not work as a main thing. But yes, a MAC address is just a set. We are going to have three. Generally, we can break it up into 4 and 2 or 3 and 3. But it is just going to be a set of digits that uniquely identify the device, and then we can associate these to MAC addresses or use these to route inside our own LAN as well.
Yeah, to repeat what Thomas said, a MAC address is unique and it's assigned to hardware. So other than a few exceptions, which we'll talk in a moment, these are basically burnt into the device. You buy a security camera, you buy a computer, and every device will come with a unique MAC address. Organizations like Optigo Networks, we have to register and request for an organization unique identifier, OUI. In general, we represent it as the first 3 bytes of the 6-byte field, but it can be 3 bytes, it can be 4 bytes, it can be 4.5 bytes. These are assigned to vendors, just like in BACnet, you have vendor ID assigned by BACnet International. These ones are assigned to us by a registration authority managed by IEEE. These organization OUIs are unique. So this is in some way like a DNA. Human DNA does not change. You could go and request for your name to be changed, but a DNA doesn't change. Well, not that I know of anyways. So that's the closest thing to the absolute unique identifier to a hardware. So coming back to what Thomas said, if let's say our networks are small, you can build a purely layer 2 network For example, some vendors do offer BACnet over Ethernet, and now BACnet over IP, BACnet over Ethernet is actually much more simple to set up, but there is a size limitation. Once you get to a certain level, there's no concepts of subnets. Where's my mouse? Yep, right.
Perfect. Yeah. So as you can see with the kind of layer 3, if you wanted layer 3 functionality, you want to be able to divide things into subnets, VLANs, you want to be able to send stuff across. Obviously, if you're public, you've our VPNs we discussed, and all these different means of using the proper internet, then we're going to need to get an IP address associated to that MAC. We're going to have it temporarily. However, if we were here, as we can see, with a switch, a layer 2 device, when the message comes in, we have our IP address coming into our LAN. But if we're sending a device, messages from a device, if it's a key card, swipe card, we have our lights there, cameras, they can actually be sending messages if they need it, but through the internet frames, they can just they can be sending with this switch. They can send the message to the switch saying, I want to send it to this MAC address, and the switch will actually look it up in its MAC address table. So we'll have a table where it'll have this looked up and we'll have IP addresses associated with it. So if it's on its only layer 2, or if it's in the switch, if it's connected to the two devices looking to communicate are connected to the same switch, then we would be able to just send without having to use IPs. But if we needed to, then we'll discuss ARPs and finding the IP address or so, or the MAC address, with different ways of doing this. But we have, if we needed to send out into the world, we might need an IP address. But here we're actually able to, with switches, just use our MACs and use that as the identifier.
Yeah, so in MAC address and Ethernet, there's really only the concept of unicast and broadcast. There is no multicast in Ethernet. And again, you don't need to understand this and retain this, but there's one bit, which is the lowest bit of the highest byte, that determines whether a Ethernet packet is a unicast or broadcast. Again, it's not that important, but typically we always use broadcast as all Fs, but specifically in terms of standards, the lowest bit of the highest byte. That's the identifier between unicast and broadcast. In a unicast frame, a switch, not a hub, which we never use anymore and it's not available on the market anymore. A unicast is a packet that goes directly to only one other port. There is an exception which is called unknown unicast, but we'll talk about that in a moment. So unicast packet goes from one device to another device, and a switch, assuming it has learned it, will directly to the right port. That's it. Let's talk about learning. It's an important concept. It's an important understanding of learning, and we'll come back to building automation and why understanding learning matters to us, especially with the use of what we called spanning tree protocol. Lots and lots of vendors now support ring topologies of connecting multiple controllers, multiple VAVs, and back into a switch. So learning, Thomas, tell us about how a switch, if you power up a switch and it's connected to 8 devices, how does it know that computer A is connected to port 2 and, or in this example, port 1, and how's computer B connected to port 2?
So if we power it up and we're looking to, originally we're going to have our devices, they're going to have our MAC addresses. So if we're assuming we're going to take DHCP and these IP addresses out of it, we're going to need a MAC address table or so, as we see in the device here. So if we want to send out, and we're looking to find out the MAC addresses or answer, find out devices that are close to us, what we'll show now is we can find different devices. But what we want to do is we want to have a switch, we want to have the MAC address table, and we want to have all the MAC addresses on this learned, so that if we have here device A, device B, device coming from these different areas, we can send them to each other. And we see a packet coming from device A here. You can see on the packet it has its destination and its source MAC. So it's going to know that if its source is coming from this port, that port is where we're going to send information if that's the destination. So it's able to, through this, kind of just learn through logic and these sort of ways that we can populate its table. And then next time someone comes in and says, we're looking for this address, it'll know it's in the table and know which port to send it out. If not, we may need to ARP and try to find where it is, or if there is anyone out there that has this MAC address, and then we can put it in our table and we can learn it and have it for next time. So it's just a way of learning and seeing where the source and destinations are coming from. If the source comes from a specific port, then the destination, if that's the destination, we're going to send it back out that port. Obviously, you're not going to be sending it to yourself, but just these different ways that we can find out on each port what MAC address is there, and we really talk about different ways of security and using this to enhance security or have learning. But it's just a matter of finding where it's coming from, where we're going to, and just keeping a record of this in our MAC address table.
Yeah, so to summarize, MAC address table is a function of a switch, and these are available in both unmanaged and managed switches, switches of any cost, any price. A MAC address table is, think of it as a dynamic white pages. The very first packet that a port sees coming in, ingress, incoming on the port, it will look at the source address. Okay, so Thomas is coming to me from this office, coming to me from that door. So I now know that if I want to reach out to Thomas, I go through that door or go to that office. That's basically what it happens. So if you disconnect to computer A in this example and insert computer D, basically you're waiting for that very first packet to be sent from computer D. Once computer D sends even a single packet, that packet will have its source MAC address, and now the switch will say, oh, I see this now new source coming in on port 1. I'm going to put in my white table, my white pages table, my MAC address table, that this computer D is connected to port 1. So that's a MAC address table, and it just learns by incoming packets. A quick note, again, without going to a ton of detail, if let's say computer B sent a packet to computer A before the switch found out about the very first packet coming in on computer A. Okay, so if B sent an actual, what we call unicast packet, so if B sent a packet with destination address of A's in this example, what would happen is the switch goes, well, I don't know where this device is. It's a unicast packet, but I don't know where it is. It will flood it. It will send out all the ports, forcing computer A to then respond. And once it responds, now it knows that computer A is connected to port 1, and now all subsequent communication will be unicasted, will be port to port. I mentioned earlier that it's important to understand this because in our industry, we're seeing in the last couple of years, almost every vendor that I know, almost all building automation vendor that I know of now supports ring topologies where they have controllers of multiple ports, whether it's VAVs or controllers, and the idea is to reduce the amount of networking ports that you need while still be able to daisy chain, let's say, 25 VAVs on the floor. It's a fantastic way of doing it. One thing to keep in mind is that each of these VAVs, each of these controllers, no matter how small or how big, it has a small address table in it. Okay, so let's say you take a controller and it has 2 ports. Internally, it will have a third port connected to the CPU of the controller. Inside that switch, that 3-port switch, it will have a MAC address. So when the ring is operational and it's steady state, all the traffic will go one direction. If you have, let's assume that you have a spanning tree protocol set up properly, everything will go, let's say for this example, go to the left. Okay, so port on the left-hand side, and suddenly one device in the middle breaks out. Okay, so it fails or it gets disconnected, whatever it is, and now spanning tree protocol kicks in, and it's expecting now all the traffic go to the right. What happens is that if I'm sending a packet and before the MAC address table has figured out that everything switched over to the right, which now again, coming back to the last page, last slide, requires all the devices to have at least sent one packet to force the MAC address table to learn that now I have to go to the right, not go to the left. If I'm sending a packet to a device prior to the MAC address tables, all of them being refreshed, it will not reach the device because it's going to go to the left. It will go to the left. It's not going to go anywhere. It's just going to get lost in the ether, in no man's land. And you can keep sending these packets and will never reach the device until one of 2 things happen. One is the device sends a packet, forcing the MAC address table to learn that now, hey, I'm going to the right. That's one. That's the easiest way to do it. Second is a timeout. The MAC address table will timeout, typically is in a range of 5 to 15 minutes. I think the typical is 5 minutes. And these are not really settings that we normally touch, but that's why sometimes you will see, if you're testing in the lab, let's say a ring of building automation controllers connected to a switch with spanning tree protocol enabled, you might see that you're trying to write or read from that VAV controller, and when you break the loop, it might take a moment for it to come back. It may take as much as 5 minutes. So that's one thing, just don't be alarmed with that. If you want more details, reach out to Thomas or I or anyone here at Optigo. We'll help you understanding this more. But again, just understanding the MAC address table maps what port a device is connected to. So in a ring topology, you actually have two ports that can reach the device, but only one port at any given time is assigned to that direction of forwarding the packet. So when the direction is changed, it may take a moment for the MAC address table to learn and to adapt. Okay, I've talked enough. Broadcast.
Perfect. No. And yeah, so that's one of these spanning trees, especially, is to avoid broadcast storms and all these, so we can have multiple connections, allowing us for redundancy without having people sending it out one end and sending it back to the same thing, same device out a different port or connection. Now, as we were saying, if we do have a situation where, let's say, we have the device here, we're connected to port 10, we are going to try look something up. We want a bit of information, or we want to look for information on port 6. However, we don't know, or we don't know where that is. Just notice that the arrows on the device. If we're sending from port 2, we're looking for everything else here. If we don't have the IP, or if we don't have the MAC of the device, what we want to do is we're going to send out that request, and it's going to flood it, or it's going to send it to each device, or else we might send out an ARP, in which case we're looking for this MAC address, or we're looking for the MAC associated with this IP address, or if we're trying to flood out different ways that we can have a broadcast frame sent out, where we're trying to search. It's basically when we don't have the information, we don't have the unicast or the MAC address the information in our MAC address table. So as a result, we're going to need to send out to these other devices saying, "Is this you? We're looking for this." And it's almost effectively we're getting a megaphone speaker, and we're shouting out to everyone, "Hey, does anyone have this?" If the device does not match this, it's just going to drop the message. It's not for him. They're not bothered. Once again, if someone's shouting in the street and they're shouting for someone else, you're not going to go up and try to talk to them. So what we're going to do is it's going to send back only when it's for them, and then it's going to go back, put it in its table, and then we'll have our put it in its table, and it will know it for future. Now, there are updates and broadcasts where we can send out multiple information, where it is just general updates or broadcasts, especially when we come to some backnet systems where they do run a broadcast more. But it is generally just where we're trying to find out and get the information for ourselves. A lot of these, when it comes to MAC addresses and MAC address table learning.
Yeah, or a lot of protocols that are for announcements, right? I am here, and it wants to tell everyone about it. That's, again, backnet is used a lot. So a broadcast is pretty simple. To summarize, a packet comes in, and it goes on every port that exists. Thomas has mentioned ARP, or Address Resolution Protocol, a lot. So ARP it's simple. It's just mapping an IP address to a MAC address. And coming back to that DNA example, it's mapping the fact that now I know Thomas is this guy wearing this yellow shirt with the Apple headphones on, right? It's mapping an address that can be dynamic in many cases to something that's physical. If you are interested, you can, if you're on a Windows machine, just bring up a command prompt and just type ARP MAC. You see the MAC addresses. I just did that on my computer, and you can see the MAC addresses are mapped to a physical MAC address, but it's also mapped to an interface. Now, my computer only has one interface, so it's pretty simple. But if your computer had multiple interfaces, you would see that by interfaces. It's the same thing as a MAC address table, except this is called an ARP table. Yep.
Thanks, yep, so then we have a sticky MAC address as well. So this can be a port security feature, in terms of that we can lock if we need to have learn the MAC addresses on a port. So, but the way the sticky MAC address works, or the way it is there, sorry, the way this all works is that we have our MAC address table, we have our table we've learned. So what we want to do is we want to not have to learn this if the switch goes down and comes back up. So we can have sticky MAC addresses where we learn the information on an interface, or the MAC addresses that are out this interface, and then we kind of associate that, so that if the port goes down and it comes up, we're going to assume that no one is going switching these or connecting these. Just allows us to obtain information after a reboot faster, as a result of us knowing where to send. We don't have to spend time relearning this information and trying to figure out again who is where and what port to send out information on. During this time, obviously, if we have a lot of devices that have come up and we don't know, and we have got a completely blank table, we're going to spend a lot of time trying to learn. And as a result, with these devices booting up and being learned, there's going to possibly be some more packets lost or some congestion. So to avoid that, we do want to stop this. Yeah, so we want to try retain information after boot. It can be a security risk to have this open or to have anything just being able to be learned whenever. So we do want to make sure that we have some association, or that we don't just let anyone plug in and we learn it on. Maybe we want to have some sort of rules where at a certain point we want to unlock our system, and also have a security feature where we're only going to let these ones that are on our system currently, or that are currently plugged in, that we have associated, be associated, so that we don't go getting so if we decide ourselves, especially in something such as a backnet system, where we won't have people jumping on and off, and we maybe don't want that. We have systems there, we can have it as a feature as well, where we only have the ones that are currently associated, and we can lock our system. So sticky MAC address, basically just making sure that we're going to stick the MAC address to a port and keep that associated there. We're going to save it and kind of assume that even if we're not regularly talking to it, it's going to be there, and we're going to lock it there, just so a system is more stationary or more quick to jump up.
I just realized, let me skip forward a few slides and just go to something that's directly related. What we call MAC address locking, also sometimes called MAC security. What Tom just described is statically assigning a MAC address to a port. So when it comes up, you don't need to discover it. Similar to that is tying a port to only a MAC address. So if you now statically assign a port to a MAC address to a port, you can also now limit it so that that port can only communicate with that MAC address, and that's called MAC security, or MAC address locking, or MAC filtering. There's a lot of terms for it. But that's a fantastic way, using pure layer 2, using pure Ethernet MAC address, to build some best practice network security. Optigo, in our solution called Optigo OneView, provides a quick way to do that. Basically, all it does is it locks a port to the connected device, so that that port is only allowed to transmit and receive information from that MAC address. So what that prevents you to do is removing a thermostat, plugging in a laptop, and gaining access to the basic network security function there. Let's go back a little bit. Just skip forward a bit. Go ahead, Tom.
Perfect, yeah. And also just to realize as well that, as we're saying, MAC address is like the DNA, it's physically locked. So we can have a attack where someone comes in and they know what sort of IP addresses. If we're leasing them or changing them, obviously an IP address a day or two later can be a different device. So it is just making sure that this, if you know someone by their DNA, obviously I can change my shirt, something can change. So we want to make sure that we have the actual device. Now in MAC address management here as well, as you can see, we're obviously going to use our own system here as our example. We can go looking and filtering through MACs. We can search for these with our MAC address management, so we can see if there's devices there. As we even said, we might have 4 or 5 different types of devices we bought. If we bought them from 1 or 2 vendors, we're going to know really, if we've only 3 or 4 different models, what we should be seeing as our first few MACs. Because as we just mentioned there, the first bit is going to be consistent. Sorry, the first portion of our MAC address will be consistent. So we can look through there and see we have cameras, lights, and doors. And then there's one MAC address that just stands out, something different. They can kind of, in this sense, we can know this, it can make it helpful. We can also filter through MACs, and we can use the MAC address as almost like as the same way you could use IP address functions in filtering or looking for it. It's just another identifier that allows us to identify the object or device.
One quick note, which we promised earlier, there is a concept of MAC spoofing. It should not be used, but operating systems and hardware now allow us to overwrite its MAC address, its native MAC address. It's primarily meant for if you're replacing a device with another device, you want to be able to still do everything. You can basically replace the new device with the old MAC address. Again, it's not recommended to do, but it's also a security risk. So it is an attack that some hackers use to spoof themselves, make them look like a device that already exists on the network and gain access.
Perfect. And then finally, just more, we have MAC address management, just more features on our own system here, where you can just see you have different ways of associating, locking, saying authorized and unauthorized MAC addresses, as we just do it by the MAC address. Obviously, IP addresses being leased and DHCP, they are a lot easier to spoof or to change. So MAC address is much easier. We can have these different rules and management to solidify security.
Yeah, and the image on the right-hand side just show that us internally, all our switches have a unique MAC address, all our intelligent SFPs have a unique MAC address, and those are all part of our ERP system. So say if you buy a unit from us, we actually know who was shipped to, when it was purchased, warranty, things like that. And we tie it to a MAC address because MAC address is unique to the device. I think that concludes this segment. Are there any questions? Doesn't look like there are any. Again, if you want to reach us, there are a few ways. You can write to us at support@optigo.net or reach us at optigo.net. On the bottom right-hand side, there's a chat box. We're always there on the other end. Other than that, hopefully this helped provide some clarity on the Ethernet MAC address and how it's leveraged, how it's used in networking. We hope to see you tomorrow at 10:30 a.m. Talking about our product, particularly called Optigo Connect. Tomorrow will be Tom and Ryan. Thank you very much for connecting with us. On that note, stay home, stay safe. Take care. Thank you.
See ya.